Hello everybody. I am trying a new format this time, and I wanted to test something new out, which is this new setup for recording my drawing. And so I kind of wanted to go over a couple of concepts of UFO flight and potential design. And I've been talking about my ideas and trying to explain them. So let's start, I guess. The most important thing here is the energy source. So let's, for starters, write our famous equation up here equals E equals mc squared. And that signifies conversion of matter into energy, or conversely energy into matter, according to the theory of relativity as put forth by Mr. Albert Einstein. And so I'm going to start with a chamber, but that's going to be our matter-antimatter reactor. And I'm kind of drawing it in the shape of a donut. This is a similar kind of design as sort of, I think, a tokamak fusion reactor. That's going to have two sort of sides to it and be also designed similar to like what the proper phrase is, a torus, right? And that's similar to kind of like the idealistic shape of so many different things: the magnetic field of the planet, the magnetic field that comes out of our magnet, or just a typical neodymium magnet. You can imagine this emerging maybe from a person, or from the sun, or from a galaxy, or atom. A lot of the shapes remain the same. So inside of here, so imagine this is made of some sort of conductive material. Ultimately, if we get our hands on it, superconductive material, room temperature superconducted material, if they work out LK99 or one of these. But inside of it, we have a lattice of kind of carbon nanotubes. And those are where you have graphene, basically. Graphene is a super strong material. Well, it's made of graphite, but not all graphite has 100% graphene. So it's really hard, though, to get these hexagonal structures of graphene. Graphene has these... It's based on carbon, obviously, but it has these very fine lattices that are all in these sheets, and these sheets stretch out, and it's the strength of these sheets, and they can lay on top of each other and cross over, and then sort of make better crossovers. I think if I'm drawing it correctly. Right, so imagine this is one sheet, this is another sheet, that kind of link up, sandwiched together, right? So the reason for these carbon nanotubes is kind of my idea, biomimic idea of sort of how the photosystems exist inside of plant cells. In the thylakoids, these stacks of stoma, is the light reactive parts of the cells in the center of the leaf, right, that make it green. They're actually these kind of webs of proteins that act kind of like little antennae that take the light, and absorb that and activate those molecules to move an electron along down the chain where it does reactions inside. So that idea is sort of driving this idea of setting up kind of this fine mesh web network of really dense, superconductive, I don't know if superconductive is the right word, but hyperconductive carbon nanotubes, possibly laced with, like, doped with certain elements. I know, like, some of the pigments in plants use, like, copper, a little magnesium here and there, some sodium here and there, kind of like thrown into the mix, right? For electroconductivity or whatever. So you have this fine mesh. And I think this could be grown. We could actually grow this. This is completely sealed and it's made into a vacuum so that you're kind of recreating the conditions, you know, similar to the devoid areas in the places between galaxies where they say that dark matter emanates dark energy that pushes the cosmos apart, all this energy. But also recreating conditions similar to the void that begat the Big Bang, where you have basically, space itself, even empty space, is not devoid of stuff. It's full of waves. It's full of all these quantum waves. And those waves come to certain peaks, right? And some of these peaks get high and they might have a little droplet, kind of like at the peak of a wave, a crest of a wave, you have some foam coming off, right? Well, this is your wave and this is your particle. Now, that sounds a lot like Copenhagen interpretation, which we're much more into an ever-ready interpretation of quantum mechanics. But the idea being you get frothy enough waves, then a particle emanates. Now, this could be a positron or an electron, or both, actually. So what they think got the Big Bang going is this emergence of particles, and those being these antipairs of the electron and anti-electron, aka positron, and those annihilate in these huge explosions, but you're left with a little bit more matter, aka electrons. Now, you don't think commonly of electrons as matter, but they do have a little teensy tiny amount of mass that technically matter, and point being you're left with extra electrons plus a whole F-ton of photonic energy in the form of gamma radiation from these high energy explosions, right? And so I don't know exactly what we get here, but you know, some amount of gamma is possible, some amount of electrons is possible from this kind of space-time horizon. First of all, we're kind of impelling with the way that this thing is structured, and then electricity is drawn from it. I think that this conductive skin could start with metal, could start with, could be graphene itself, just solid graphene, and or LK99 when we get it, but that could have an extractive quality too, conducting this energy out. And the second part of this equation is a couple of Vajra turbines, which the Vajra, I have to say this part of the idea kind of came from a video with Randall Carlson talking about these plasmoidic generator concepts that they're using, combining them with internal combustion engines to make it more efficient by basically using this implosive energy combined with an decompressive energy to create these kind of toroidal bubbles of energy emerging from solution. In this case, it was, I think, water. They're creating these little plasmoidic bubbles in water. So, figure out which way I'm going here. Okay. So they're oppositely timed, oppositely oriented. And the idea here being these are coils, and these will take energy and funnel them downward. You're creating kind of a magnetic cone to fine-tune and focus magnetic fields, electromagnetic fields, or electric and magnetic fields into this tiny space in the center of this torus. I don't know exactly yet if these end in a point, or like if they need to end in a point, or just another circle. These aren't connected exactly here, right? So these are going to be isolated on their own circuit. The whole thing here is this creates kind of a circuit. So you're extracting here, you're imploding here, you're extracting here, and you're imploding here. So this gets pinched by this. So you're bringing up the force of the energy. I suppose you could alternate these. So you're creating explosion here, explosive force, as well as pulling on this with the fact that you're doing work with it. I know that sounds a little weird, but I think it kind of can work like that. If you're designing your circuit to sort of, I don't want to say feed off of itself because it sounds too much like perpetual motion. You're not getting something for free here. You're returning a lot of this energy back onto itself, so as to cycle up this process and increase the, frequencies, energies associated, increase the threshold of your reaction, let's say, through this pushing and pulling of this kind of throbbing energy source, right? And you've got this all the while. You got an explosive force taking your energy and extracting it out, and you have an implosive force pushing it in and alternating those. You could probably hook this up to some sort of alternating energy current to get these up pretty high. And it is possible it could price match, so to speak, whatever your workload is. So if you're hooking this up to a AC system or a pulse DC system, it could accommodate. You could change some polarities. Somebody that really knows electrical engineering could probably make hay of this video and correct me on a lot of things. So then conversely to this sort of setup that we have this vacuum chamber for extracting this energy in the outward direction, we also have, I'm thinking, a couple of vacuum chambers that are condensing energy, some of this energy. So you got to think, like, not all the energy in this system is going to be moving through the wires. You've also got this huge magnetic fields that are all going all over the place, plus a lot of radiation besides. But plus all, so you've got a bunch of cosmic radiation always moving in from the universe, from all sides, and all that. And so you could theoretically, pull some of that in to your system if you had the right, orientation. So thinking that this entire thing is kind of a harmonic oscillator for electromagnetic energies, and that it's orientated similar to the magnetic field of the planet. This is a harmonic energy generator in the sense that you can possibly cajole random cosmic energy particles to come in here. Normally we don't think of those things in our electronic circuits, but if it maybe even not to put it right to use in your circuit, but if it encourages a greater threshold of this push-pull pseudo-fusion antimatter-matter collisions reaction, then that, is increasing the threshold of your reaction, and then you're getting it out, you're getting your actual useful energy out of these coils or something like that. Then you've got something a little more workable. P.S. You're probably going to want to do a fair bit of shielding, right? So you're probably going to put some sort of like lead-based paint all over this, some Faraday shielding in between, maybe get these coils as tight as possible so those sort of, do your Faraday shielding and kill two birds with one stone, right? Like, so those are picking up any beta particles, any flying around neutron decay, any of those big bad boys, right? And those are going right into the coils, similar to the way helion energy does their fusion extraction. There's a solid state, so this is using some of that too, inspired by, and that's really the best way to do fusion, because going all that work to do fusion, just to boil water, is so silly. So the way these things work, supposedly, I'm thinking that this would be a conductive kind of cap, right? And that would be sealed here. There would be a rubber seal, and that would be non-conductive. It would be an insulator, and that would be sealed to kind of a metal cone that, similarly to the inside of this, would be laced with these carbon nanotubes that would be grown or reacted, electroplated through a process. I'm looking into ways to get graphene and carbon nanotubes to grow like this. Apparently, you can get them to do so with certain combinations of carbon, and by treating it with fire, you can get these things to show up, if provided there's enough oxygen in the mix. And some of the techniques around making biochar and activated charcoal actually intrigued me. So I was looking at Mousseau black paint, like this ultimately black paint, but I'm wondering if possibly, getting, cultivating a mesh or plating a mesh, aka growing a mesh onto these things would produce such a blackety black that I don't have to worry about Mousseau black. And then, don't have to make already paint conductive and then mix in metallic particles, possibly make it shinier and then ruin the absorbent qualities of it. I'd just make some hyper absorbent carbon nanotubes, right? Just homebrewed, right? So inside this, very similar, you got a carbon nanotube mesh in here, burnt on, and that's collecting these rays that are coming through, and also these rays and any particles that might be escaping here and there that are caught up in this magnetic flow between the sides. You can imagine possibly each of the hemispheres of this, by the way, are probably going to be isolated. Each of these hemispheres are going to be isolated. But I'm imagining that the direct connection between this conductive surface would go to this conductive surface, and this metal conductive surface or graphene conductive surface would go to the middle of this. So straight from this to that on these vacuum chambers, right? And then this side of the, make it clear that that's what that is. This side of this one going to this, I think, and these connect. So there's an electrical conductivity in between this side and this side. So yeah, your electricity and particles, your electricity flowing here. And then the inside of these caps is coated with some sort of super white, hyper reflective material. So, and this outside is conductive. So you got gamma flying in here, different high energy particles flowing in here. But this works like a condenser, and these coils are also helping that condensation. And these, they're getting trapped in here, they're bouncing around, but they can't, they have to go down, right? This is reflective, hyper reflective, in fact. So you got some titanium oxide paint would work, but you've got barium sulfide and a couple others that you could use. There's some videos out there for how to build ultimately reflective, cooling paint that is so reflective it could actually cool a building lower than ambient temperatures. And so this is reflective and this is hyperabsorbent. Same thing happening here. And then I imagine, so we're probably going to want some coils. And these coils on this one, they're not going to be going straight up and down as in your stellarator or whatever. These are going to be probably oriented, ideally according to Maxwell's field equations, but probably letting, I hate to invoke the name Marco Rodin, but looking a little bit more like a Rodin coil. And possibly crossover. So if you have these going this way, then you got these going this way on each side. And those are doing some of your Faraday caging from the whatever's coming out of the inside, so your gamma is not flying right out here, just in case some get by the carbon nanotube mesh. Ideally they don't, but this is, picking up on these massive electromagnetic fields, any of this neutron decay, radioactive decay from neutrons or anything like this, going into your coils. And so effectively these massively amazing magnetic fields are going to be producing energy in your coiling system. And that's where your power is mainly going to come from. And again, in the future, room temperature superconductor, or graphene might probably make a better conductor than, so carbon nanotubes themselves, if we had them in access and the ability to make coils out of them, that would probably be better than copper coiling, given that we're going to be using this for high energy purposes, such as local gravity production, let's call it. I don't want to say antigravity, because that's not quite right. It's more like gravity neutralization by creating a more localized gravity field than what you experience on the planet normally. So, so then these are going to be conducted. So you got your coils coming off of here, say, collecting from all of the outer ones, because your energy on this, your electromagnetic field and everything on this one's going to be moving out. So you're collecting from the out, right? And this is where I think you can do some work. That'd be like a negative energy lead there, because your electrons are coming from it. And these, you can go do some work, maybe plug in a light bulb, or a power supply, or computer, charge a battery, and you're putting that back into the start of this, right? And marrying these two. Okay? And so then you got, and this power is moving down here. What are we going to do with what's coming off of the coils down here? Well, we're going to plug that back into the beginning of this coil here. So there's your circuit. It's down here, into this coil here, not onto the conductive surface. That's its own thing, right? That's isolated. There's a conductive relationship between these, but that needs to be driving the magnetic field. That's to get the magnetic field up to snuff to drive the coils to make your energy. That's what you're going to use. Otherwise, I believe, I'm not sure, I don't think those need to be connected. I think that it's similar to a Tesla coil. You're resonating upward, right here. So this is you're getting this going as a resonance to increase the size of the field, and then that field is driving higher energy use, and you're getting something off of that, if you're lucky. And so if we do everything right, we can do that. So I don't know if we need to go to propulsion from here, but there you've got your light bulb, but you could run some superconducting plasma conduits, or LK99 room temperature superconducting conduits, if we get that, out to some plasma generators that are on the outside of your metal skin ship. Let's say, just imagine, this might be pretty big. This might be to scale. Could be much smaller part of the ship, right? And then it's kind of, there's like a, let's say, a walkway, like a platform, and mainly this is all left to human habitation, provided enough shielding on the outside of the craft here, and, shielding here, and here, a lot of which is the coiling itself, capturing any other stuff, right? And you've got plasma conduits, so imagine a bunch of these coming out here, and plasma emitters. Now, as Sal Pais would say, these are, I think, asymmetric plasma. Maybe I'm not getting that right, but they're cold plasma. They're not usual plasma. And you're also modifying those and increasing the resonance with terahertz frequency emitters, right? So you're emitting plasma. Imagine you're making a tiny little cold fire here, but you're also hitting it with these frequencies so as to fine-tune it, and with greater precision and harmony you're getting this plasma to higher and higher energies in smaller and smaller and smaller spaces. So you can theoretically mind you, warp space-time. You can engineer the fabric of space-time. Think of it like maybe building a small enough needle or nail, right? So you can't punch a hammer through a wood board, but a nail can punch through. How does it punch through? It can get through that fabric, right? And the fabric of the universe is space-time, and it's a pretty tight fabric, but it does have its limits theoretically, and that is what we call the Planck time and the Planck scale, which I don't know the figure exactly. It's 10 to the negative umpteen bajillion small, but it's much smaller than an atom. It's much smaller than quarks. It's the smallest, call it the pixel size of the universe, right? So you're getting smaller, as small or smaller than the pixel size of the universe, with these immense amounts of energy. And, sort of by connecting this negative, so if you have you're developing here a negative energy curvature, right? And that's what you're doing. And space-time, a negative curvature looks like this, a hill, whereas a positive curvature, which is like, the Earth or something, is a trough, right? And you're kind of positioning your ship to be between these, although this isn't a typical ship like, your Zap Brannigan Starship, right? It goes this way. It's got a discernible front and a discernible back. This is more like you're actually making this negative curve inside of it, and this front between, call it the hammer, the blunt, and the nail, the sharp, right? That's more the way to think about it. This is less dense, and this is more dense. And so you're really surfing a wave between a gradient of density of space-time. And so you don't actually have to make this wave out here. You just have to have these emitters that are capable of punching through and making these intensely energetic spots at the Planck scale. And that's, so you're punching, and going in these different directions. These create called that a warp bubble, and by doing so they connect and create this magnetic field, this carrier wave, this field around connects, and these sort of work like antenna for this field. So these emit here at the hemisphere, and collect here. I'm not sure if you'd have this radially along the middle. This might be better to actually, you have two levels, right? One for above, one for below. As above, so below. And those you've got, so it's creating one half of this this bubble here and half of this bubble here, right? Where they connect. You could theoretically create variations between how the bubble is curved here versus how it's curved here, right? And that essentially, the theory of Casimir gravity has that. Gravity is actually a result of a differential between the size or complexity of the waves of space-time, the quantum waves, right? So presumably, if you normally how gravity works like this, you have larger space-time wavefront and a smaller space-time wavefront, and that goes to that, right? Things are at rest on the planet. Right, they're sitting on the surface, mostly at rest. The activation, the energy is not very, very high. Your quantum waveform is not terribly complex, and there's not a lot of potential energy there, right? But up here, you're up in the clouds, you're up in the sky in your airplane, and you could potentially crash down to Earth. There's a lot of energy there, and those differences between these two potential energy systems close, right? But here, you could potentially engineer it in such a way as the one on the bottom is bigger than the one up here. And that, so there you have lift. But take that to the nth degree, and you have a warp drive. Since you've made a warp bubble, right, so you're outside of space-time in the strictest sense. You're not inside of this thing. You're not a piece of baryonic matter. You're not being affected by the rest of the universe. And if Mike McCullough and others are right about inertia being the result of a kind of radiation, or that, so if you're connected to the rest of space-time, then you have inertia because it's the result of you moving through the physical world as we understand it, right? And can't have those interactions if you're outside of the normal context of the flow of space-time. Sure, there's probably rules here, but you've got these set up, and you can create a gradient. You could maybe even create. Some people think you could even create microgravity. Right, so by varying these in small ways, you could create a distortion there. Not necessarily even through acceleration. You wouldn't necessarily feel acceleration actually with the outside world. You wouldn't feel inertia as we know it. So those concepts don't apply. But you could modify the structure of the. If you have all this ability, it's not too much farther of a stretch to modify the space-time metric to achieve artificial gravity. So you could have people walking around on your little platform, looking out the windows and stuff. And you could have like your engineering down here, your Jeffries tubes. It's funny how these actually seem a lot like Jeffries tubes, and cargo and steerage, maybe some quarters, all that kind of stuff. It's not very complicated besides that, though. And to talk about control, similar to, you got a quadcopter, an octocopter, right? And that's by controlling the different fan blades, right? And then you spin this up, or you take power away from here and here. And that's how you control a quadcopter. Well, this is similarly oriented dimensionally, so you can control the power going to each of these with some sort of switch, manual switch. I don't know if you'd want to clunk a switch, but let's say you do get a room temperature superconductors. So these superconduits are made of room RTSCs, and that's not great, because then you're constantly going in all directions. You're going to rip yourself to pieces. So you got to have some sort of control. you could do so by alternating these. So on this side, let's say you want to go this direction, you increase the threshold of the throughput. You could do this with superconducting gates. Let's say this is all, so in the original model, we don't have room temperature superconductors yet, so this would be some sort of superconducting plasma or Bose-Einstein condensate. It takes a lot of energy to do, kind of a pain in the ass. And then this could be kind of another Bose-Einstein, or conversely superconducting plasma or cold plasma that is being changed in how superconductive or conductive it is. So you could turn off, vary the conductivity, right? So more conductivity moves this way. You know, you're punching the hole, right? Stronger, and right, you could take power away from this one on the opposite side, resulting in move that way, right? Or this, the opposite, in the opposite direction. So then you can start to see how these things in the sky move all around, like some people say, like a mouse cursor in the sky, right? So it kind of makes sense. They're not experiencing inertia, gravity, or really any. Their relative, their frame of reference is their own relative to the universe itself, not beholden to any local gravity fields or anything like that. Friction, inertia, anything, solidity. They're completely on their own, and that makes sense how they could pass through solid matter, just go in and out of the ocean whenever they feel like it. Maybe they're going to bases inside the Earth's crust. It wouldn't be a big deal once you have this. And we'll get into multiversal travel and other timelines and stuff like that on another go. But I believe I've been going on like this for over 30 minutes. So I'm trying to think of what else. I got the gates. This is how you would control it. Not sure so much how you'd navigate. Could be manual control. Some people think you need conscious control. I'm not sure about that either, because you'd have kind of normal space-time flow inside here. It's not like you need to be super fast, super luminal thinker or anything. You just control it like you normally control it. It's here. Space-time relatively moves the same way internally. It's relativity to out here that you need to think of in superluminal terms. So it's just moving around, man. It's going here and there. I'm not sure if you need really crazy calculations for warp speed or space-time travel, or you just go, right? You orient your ship and go, and you just hit those velocities as you need to. In terms of how fast you could go, I'm not sure. The aperture, the performance aperture, is really to the limit of your materials, right? The better materials, you get better carbon nanotubes, or maybe we discover that that's passe when you discover some amazingly absorbent material that's even better for absorbing gamma and distorting space-time for a negative space-time warpage, or we discover, we get those superconductors, and maybe there's variations on this design, and we see all sorts of craft. So that, and yet a lot of them seem to be violating, not violating, but we'll just say creating local gravity, modifying space-time at their whim, possibly through electromagnetism. And there may be a bunch of ways to design something that does that. But this is just the result of, everything I've seen and done so far. Of course, it wouldn't look exactly like this. This is conceptual drawing, so, to kind of treat this with respect while I explain these concepts in a visual way. I've rambled before, and have done drawings before. This is my first time trying to blend the two. And So if you got any questions, please smack them down in the comments, and share this if you enjoyed it, and like, subscribe, consider donating to me on Patreon, PayPal, or Cash App, and interested in building something like this, although I'm sure that we could get in trouble for actually doing this. But if for no other reason than understanding what may be going on when we see these things flying around and how they may be working. So at least some elements here could be useful for something. And essentially, this is interesting because it might seem bizarre, but it's no more really counterintuitive than a neodymium magnet, right? Where's the energy coming from in a neodymium magnet? It's coming from kind of the shape of the universe and the shape of the electromagnetic fields themselves, and the potential force between two magnets is the Lorentz force, and it's all the same stuff that drives, Newtonian mechanics and general relativity and all that. It's very, very much the same, and it's just an organization of the materials that are tapping that. The organized geometry of the molecules inside those neodymium magnets that's guiding the natural extant energies and geometries of the universe to produce those. And then, so essentially, the force the two neodymium magnets have when they attract to like poles to each other is almost the same and experiences the same acceleration relative to time and distance as maybe not exactly, but similar acceleration, inverse squared proportionality as gravity when you fall to Earth, more or less. But the point is, it's a logarithmic acceleration as they get closer and closer. And I think that points some things out. So you're basically just building a giant magnet. And, it's got some electrical parts, but we overthink a lot of things. We overthink too many things. The idea of fuel is take a potential chemical energy and thrust it out the back of a chemical rocket is so passé when you know that with a little intelligence and some metamaterials and some things placed in just the right way and oriented in just the right way and pushed and pulled in just the right way, you can create something really beautiful, harmonious, and amazing. And with that, I suppose I should give it a rest. Thanks for listening. Thanks for watching. I hope this was educational to somebody. Have a good one. Bye.